Our first speaker is Dr. Amy Fulcher from the University of Tennessee. She's leading Objective 1. She's going to talk about some of the automation that we're producing and also automation that we are testing.
Yep, great. Thank you, Anthony, and thank you all for being here and for the opportunity to work with you all. All right, so we're going to start by talking about Andrew, which is the herbicide applicator that George Cantor's lab, Billy Herod, a graduate student in his program, they're both here. And they did the demos earlier today, as Lloyd mentioned. So we'll just give you a brief update on all of these pieces of technology and then where they're headed. So what they've done in the last year since we met was some initial testing for drivability. They found that the modified version of the Amiga that you can see that they retrofitted it with caster wheels instead of the 4 original wheels, traversed the terrain without any problems. They did discover that our pot and pot was a little more narrow spacing than what we had anticipated from measurements at nurseries that Anthony and I had taken. I want to just quickly address a point that was brought up earlier. So we looked at the Burrow, we looked at the Amiga, we looked at the Husky and some other systems. And 3 of the 4 engineers are currently using the Amiga. We wanted to coordinate so that we would have some synergies of working through the same issues together. And also because at the time it was owned by Fulcher, and they had a good track record developing peripheral items or pieces that you can buy along, and that would be a great way to partner potentially in the future. There was the inability to purchase items as a federal entity. Our USDA partners could not make purchases for a long time last year, but had this existing robot. So they went on and worked with that because they had it, but they'll be transitioning as you'll see later, and then also have a standalone version. So just appreciate the opportunity to explain that so that everyone knows where we're at with the system, the electric tractor platform that we're using. So Billy worked on the second iteration of the navigation payload, the map building capability there at Willoway. And again, we thank them for their partnership on it. They're working on the autonomy development now. Billy's also been supervising a team of undergraduates at Carnegie Mellon this summer. They designed the actual sprayer part of Andrew, and they developed a really interesting weed detection vision system. So they will be working on that as summer goes on. They did a demonstration earlier today. They'll continue working on and complete the sprayer subsystem this summer, as well as integrate autonomy and spraying. And then as we get into fall through January, continue to test and do iterative changes and improvements. And then we will get to start testing next year. So really moving along and making great progress. And we're happy for Billy and all the work that he's done, and sad that he's graduating, but he's put in a lot to get to this point. The next one that I'm going to talk about is Piper, the pot and pot extraction robot, and that's led by Dr. Hal Gann at the University of Tennessee. I help a little bit, but he's got 3 fantastic students. They've done an outstanding job. All of the students have. This is what the Amiga outfitted for our current prototype looks like. And this will help with pot and pot, but my hope is that it also will help with lifting pots that are on the ground, all of the above ground container production. We have a lot of big trees. So what they worked on was developing an end effector, and this was one of Nathan's jobs, and Nathan tested a lot. He did a lot of 3D printing. He did a lot of iterations before getting to this particular design that is working very well on the pot. They also developed a system to tell when that end effector has hit the sidewall, the top of the sidewall of the pot, so it doesn't just keep going down and crunching the container. They developed the computer vision algorithms to test the pot and locate the target pots. Ling and I went out to Halen Hines Nursery, took a lot of photos one day photo after photo after photo to train her system. And then here on campus, you can see they're testing Piper and the end effectors there. One of the nice things, this group of graduate students supervised 6 undergraduates, a team of people that participated in Bonsai's Farm Robotics Challenge. So that was a really great experience for them, a good learning experience and good supervisory experience for the grad students. Their future plans for the 3 different components to the Piper project are redesigning the arm system to overcome the current challenges that it has with weight and with flexibility. They'll be developing the adaptive control algorithms to more accurately pick the pot, and then develop a complete navigation stack that includes pot detection, localization, and autonomous navigation. And that's Ling's part. And all of these will involve field testing. We're building a pot-in-pot, very small test plot so that we can work out the kinks while we're in Knoxville before we head 2.5 hours out to the nurseries. The next piece of automation is Tally, the terrestrial automated laser-based inventory system. This was tested earlier today, so some of you maybe had a chance to see it. And this is twofold. Hopefully you were at the demo then. There's two parts to this. So this is commercially available through Smart Apply, and you can see that it is attached to a side-by-side. It could be part of their spray system. It could be on a tractor that you mow with, or a mowing like zero turn, so that every time you're performing those activities, you get inventory. There's also the robotic the self-navigating autonomous system that they are building. And right now, Dr. Zhu and Adam are testing that in apple orchards because they've got those handy, but they tried them out with some potted plants today on the loading dock, and we got to see how that worked and see the point cloud map and all. All right, so our final piece of technology that the team is developing is AIPM, Artificial Intelligence Pest Monitoring System. And this is being led by MD Sultan Mahmood at the University of Georgia, and he's working with Carla Adesso, who's an entomologist at Tennessee State University. And like the other teams, they've made a lot of great progress this year. They take their images, they stitch them together, then they segment those images, and you can see they've trained their system to pick out the best trunk that most fully represents the actual trunk there. They manually annotate, that's what the little yellow dots are, the Japanese maple scale that is present. This model system is being developed using Japanese maple scale because it is very small, very insidious, very hard to see as a human. So we're hoping that the machine can see it better. And then they develop these patches. They have positive and negative patches for training the system. So the positives are examples of a picture or a part of a picture that has Japanese maple scale on it. The negatives either have a black background or trunk, but no Japanese maple scale. And they ran this through 2 different tests. They had good accuracy, good predictive ability. And now they're moving on to conducting their field testing, deploying it as part of the autonomous robot using the Amiga, and going from incidence, which is presence absence, yes, we have the scale, no, we don't, to developing a severity rating and identifying different colonies of the scale. So one of what Dr. Mahmood is proposing is 0 to 15% would identify a low infestation level. 16 to 40% would be moderate, and it's represented with the yellow. And then 41% or greater infestation would be considered high. So we could maybe have a conversation about this. This may not be static for all pests. It may not be the scale that we want for this pest. So this would be a great place for growers to weigh in when we have some time. All right, so now we're going to move into sub-objective 1.2, and this is where we are testing off-the-shelf products that exist. We're using them to help growers become exposed to what is out there that they might not already be taking advantage of. So first, I'll report on the herbicide work that Chris is doing. Chris Marble at the University of Florida has led this sub-objective. He has been testing various forms of application equipment. So for efficiency, uniformity, distribution patterns, he's tested these at 8 different Florida nurseries. And we'll look at a few pictures of some of his work and get in a little more detail in just another slide or two. He's generated data on multiple methods and forms of application. So whether it's a belly grinder, drone, and a couple of different types of boom sprayers, looking at man hours, for example, the number of pots they treated in a certain amount of time. He and Margarita collaborated on a survey and collaborated with Cherry Lake, who made that survey possible. And then there are a couple of surveys coming up that we'll talk about. One of Chris and his students' big efforts this year was looking at application volume, because this is something that has come up with growers over the years. So here we've got 25, 50, 100, and 200 gallons per acre for liquid herbicide being applied. We have plants. These were originally planted with gardenias in the back row and fallow pots, no plant in the front row. On the left, they were irrigated right after treatment. On the right, they were not. And so Chris and his student found some interesting results here, because it looks like a very small volume can be effective if you irrigate afterwards, or if you have a smaller plant. You know, it opens the door to that. He also assessed how the canopy was affecting the spray penetration, getting through boxwood, podocarpus, crepe myrtle, and roses. You see those across the bottom. And then for the sake of time, we won't go into everything Chris did. It was pretty exhaustive look at herbicide applications and applicators. But he also looked at single pass, multi-direction passes, and the nuances of making that herbicide application and its impact on efficacy. So Chris is going to continue to evaluate equipment. He has collaborators in other parts of Florida, different nurseries, as well as in a few other states in the Southeast and in Oregon. He is going to be disseminating a survey to 21 AirTech customers, very kind of specific survey, and then a very general survey for herbicide applicators of all types, regardless of what equipment that they use. He's also going to be collecting data from nurseries where the same applicator makes granular and liquid applications to get some of their feedback. He'll be publishing his work in extension publications and peer-refereed articles next year, and he is one of the team members who will be testing Andrew whenever Dr. Cantor has that ready for us to start. Next, we'll talk about the fertilizer applicators, and this is something that Lloyd, Anthony, and myself all work on, along with our teams at our respective universities. As far as some of the work done in Oregon, they looked at the Fertil backpack, the Fertilise Pro 35, a broadcast spreader that Scott sells, and then the traditional spoon and bucket method, and felt that the Fertilise was the fastest and most consistent. The broadcast spreader was fastest at scale, but then required more refill stops than the Fertilise. And an interesting point, like fatigue from pulling the trigger on the Fertil came up at both sites independently. And one of the general managers expressed some concern about that leading to some kind of chronic injury from wear and tear. Sorry, this is not wanting to cooperate. It stole my thunder. So some work that we did with Easy Tree Nursery, and James and Terry are in the room here. Okay, I can't play the videos with this, but that's okay. I don't think we have time for that. So we had the spoon and bucket here, and Cesar and Rodrigo were instrumental in this. And then we tested that against the Fertilise Pro 35. We found that when we were using #2 containers, so the Anna's Magic Ball growing in a 2-gallon, that fertilizing with the Fertilise was 100% faster and 70% faster with our 3-gallon sized plants, which were Itea virginica Merlot, so very different size and shape plant. We left our 2 Pro 35s with James and his crew, and we were excited every time we went back. We were told they're still using them, and then I learned from James that he bought several more. They have 10 now, so I don't want to steal any of Margarita's thunder, but just remember that the workers chose to use it, and the owner chose to buy it for his workers. And then we'll let Margarita fill in the rest of the story on that. We did a survey with Cesar and Rodrigo and asked them about their perceptions of some things, their perception on energy expended to fertilize in each of these 2 ways, the spoon and bucket or the Pro 35. We asked them about their comfort level, their mobility, how accurate they thought they were. They didn't measure that. And how quick they thought they were. They didn't measure that, just their perceptions. This was a 1 to 5 Likert scale. So based on using the Pro 35, they used 1 point less energy. They had 2 points more comfort, mobility, and accuracy, and they felt that it decreased their time by 2 points. All right, so moving into, I'm not going to switch back again. So into irrigation, and this is the last of the off the shelf. So you remember we talked about the number of growers that still manually open and close irrigation valves when we met a year ago in this room. So we have since worked with several of them to install Bluetooth irrigation controllers and long-range radio-based irrigation controllers. We have a number of partners in Tennessee and North Carolina and in Oregon. And you can see here the Toro Tempest system with the Bermad flow meter that integrates into the app. And here the Solum system with the soil moisture sensors that also integrate into that system. So we'll continue in Oregon and North Carolina. These were set up this year, so we're kind of on the front end of data collection. In Tennessee, this is our 2nd year, and these are representing 4 different zones. The zone the grower manually controlled. We added a leaching fraction based control system because we already had it at this particular grower. And then these 2 zones are the 2 Bluetooth based. And I'm a little partial to the leaching fraction zone since we developed that sensor and that system, but I think it did the best. It had just as many flowers and used the least amount of water. That orange is for UT. So the least amount of water here cumulatively over the season. The 2 Bluetooth sensor based controllers used the most water. There are actually 4 plants here. It doesn't look like it, but there are. But this echoes what I know from studies done over the years. Manual irrigation is really variable. This is real. They really did leave it on and it ran that much. And there really was this long flat period of no irrigation, and this one as well, and this one as well, and this one. So a lot of variation. And usually we see about 3.5 times more water applied when irrigation valves are manually controlled. In this case, it was the opposite, but there's a lot of transition going on at this nursery, so it is a little different scenario. We're going to be moving forward with continuing these irrigation trials. Fertilizer trials are complete, so we'll be working on extension publications and trying to spread the word about the results that we've gotten. We have scientist stations planned for IPPS Southern Region and Houston. In fact, Chris and Anthony and Jeb Fields and I are going in a week and a half to set those up, get those trials started so that they will have matured and you'll be able to see the results when the group is there in October. And I'd encourage you all to come out to that.
And this microphone right here. I'm gonna set it for 3 minutes. So if you all have some questions, either in the room or on Zoom, you'll say it into this microphone. It's not going to amplify in the room, but it goes to Zoom so they can hear you ask your question. So you would sort of walk that over. But it's sort of back and forth. So you have all of objective one. So all of the various pieces of automation, Andrew, Tally, Piper, AISTN, some of the other technologies. You all have some questions to ask some of the developers. They're in the room, some of the researchers. This is Tim from Bailey Nurseries. When you were watching the videos today, you were watching, I mean, the demos today, you were asking a lot of questions. Can you just tell us what your experience has been a little bit with automation? Can you take roughly 30 seconds? Is that possible?
Sure. I'll try my best. Yeah, so I'm doing our drone operations at Bailey Nurseries. So we're using a large spray drone and then a small Mavic 3M multispectral drone to automate some of our inventory for shrubs in Barrett fields. Which works very well. The time frame to get good images is very small. So looking into this LiDAR based stuff is very interesting to me because that could be used in our tree production. So yeah, we're currently just using the drones for as much as we possibly can, measuring acreage in fields, calculating pile volumes for our media that we're using. And I'm just super excited to see all this other technology out there. Would love to be a part of it. So very happy to be.
Excellent. Thank you very much. Anyone else have some comments? We have 58 seconds. Objective one. All right.
I'm kind of curious about the AIPM for the one insect that it's scanning. Is there plans to be looking at more insects in the near future?
That's the question. He's asking about the Japanese scale for AIPM. Dr. Mahmood is not here. But Japanese maple scale is one of the most difficult insects to count, and control it causes a lot of damage because it looks just like the bark. Window in which you can control it. On their arm with scale, and then like it will. So I can't really speak for him, although of course we're going to get every insect possible. But this is one of the most difficult ones and very different. Thank you. That's our 3 minutes. But I am sure we could translate it to other insects and other crops on a second round of this grant, perhaps. But I couldn't. We're focusing on Japanese maple scale now. All right.